Hello everyone. In last two presentations, we have started discussing the combined problems of UV, IR and NMR spectroscopy. So in the same series, let's continue and discuss third problem. So molecular weight is 174, UV 213 nanometer. So that is indicating absence of conjugation. If we read IR, then 29412 2837 1745, that is indicating presence of ketonic group, and 1458 centimeter inverse. There are three NMR signals: triplet delta 1.27 16 square, second signal B singlet delta 2.6 10.8 square, and quartet signal C delta 4.14 10.4 square. So as we did in last two sum, immediately before you start solving the problem, we should check that which are the immediate informations we are getting. So as I said, 213 is indicating absence of conjugation. Uh, this IR is of the sp3 hybrid carbon alkane stretching. Important is this one, 1745. That is of the carbonyl group. So carbonyl group is present. In NMR, you can see that triplet quartet indicating uh, ethyl group, and molecular weight is high, 174. But if you notice that from the delta value of all the three signals, we can say that compound is not aromatic and molecular weight is high. So now we start solving the problem. These are the immediate informations which we have already discussed. Molecular weight high but not aromatic, carbonyl present, ethyl group present from the NMR. UV already we have discussed, absence of conjugation. 3IR first range is of the alkane stretching. Ethyl is present, so alkane stretching is present. 1745 is a characteristic of carbonyl. 1458 is alkane bending. So from the IR, the significant information is presence of carbonyl. Now let us analyze NMR. First, let us calculate the proton ratio. Square values are given, so we always divide all the values with the smallest one. So 10.4 is smallest one, so 16 by 10.4, 10.8 by 10.4, 10.4 by 10.4. So this answer is 1 and 1 half. This is almost 1, not exactly but almost 1, and this is 1. So proton ratio of all the signal 3 is 1 and half is to 1 is to 1. So it is in the multiple of that, so maybe it is 3 is to, if you double the value, then 3 is to 2 is to 2, or it could be 6 is to 4 is to 4. It is always trial and error. Already we have discussed that signal A and signal C indicating ethyl group because combination of triplet and quartet. So later on we will subtract the 29. Signal B 2.6, slightly high delta value, and mostly it is 2 protons, so methylene group is present, so its weight is 14. Already we have discussed about proton ratio of ABC, 1 is 1.5 to 1 is to 1. And this delta value which I have highlighted with the color code red, slightly higher, though it is a methylene group. So we can say that higher delta value which indicates that this portion must be attached with the higher electronegative element, which could be the reason of increment in the delta value. So we have discussed about UV, IR and NMR. So now let's subtract, because all the three signals we have solved. So whatever we have identified, let us subtract it from the given molecular weight. So 174 is molecular weight. Let me tell you friends, you have to show this subtraction exactly in the same manner in your final answer also. So let us first subtract 29 of the ethyl group, 145 left, methylene group signal B 14, so 131 is left, and 28 of carbonyl group that we have determined from the IR. So 103 left. So Let me tell you this example, why I have chosen this example. Reason is that it is a special example because 174 is molecular weight. It is not aromatic, because if it is aromatic then considerable part, because we know that monosubstituted weight is 77, di substituted ring is 76, tri substituted is 75, but this example is not aromatic. Whatever we have identified from the NMR, all the three signals and IR, if we subtract them, then even the larger part is left to explain 103 from 174. So this is a problem because we have subtracted everything, and even after that 103 is left from 174. So now what to do? So friend, let me tell you, in such a situation where from the given molecular weight, whenever you subtract everything and even after that larger part is yet to explain, so most probably the answer may have the mirror groups. The meaning of the mirror group means certain portion must be present twice, right? So in such situation, what you should do? First, you should try to justify the half molecular weight. So half of the 174 is 87. So from first we will try to identify the 87, and then if we can solve that, we will consider that that portion is a present twice, double. So again let us do the calculation. 87 is a half of the 174, this given 29 ethyl, 14 is this methylene, and 28 is carbonyl. So now we subtract all these three from 87, so 16 is left. Now there are several combinations we can add for the 16. One is oxygen, atomic weight is a 16. Another possibility is NH2. So friends, always remember that there are only three signals are given and we have solved them. So anytime, whenever you want to add this remaining value, you can never add any more protons because you have to justify the signals. If you add NH2, it is a 16, but always remember that if you add NH2, then there should be the fourth signal. And for the NH2 group also, IR should have the band in the range of 3000 to 3500. Both things are not given. So you cannot add NH2. So ultimately the only option left with us is oxygen. So oxygen is left. So apart from these three parts, ethyl, CH2, CO, we have to add one more oxygen, then we can justify 87. So here it is, CH2, this is signal B, this CO and one more oxygen. For that remaining 16 we added CH2, CH3, that is ethyl group for the uh, triplet and quartet combination. So this is the justification of 87, and this portion must be present twice. So see, this one time and this is second time, and both parts are attached, so we can justify the valencies of these hydrogens, CH2, CH2. You cannot write only CH2 here. Now let us check the NMR. Your signal A, right? Now signal A having 6H. So if you remember, when we have solved the proton ratio, it is 1 is to 1 is to 1.5 or 2 to 3 or 4 4 6. Purely trial error based. Actually our problem having this proton ratio. So signal A 6H triplet, signal B 4H singlet, and signal C 4H quartet. And the name of this compound is a diethyl succinate. Let me explain you how. If we consider here carboxylic acid group COOH, only this portion with H, it is called succinic acid. Two of its protons are displaced by ethyl group. So the name is called, this is ester. So name is called diethyl succinate. So friends, this is little bit a tricky problem. Now you must have understand that because molecular weight was given such a high, even after subtracting everything from the NMR, a large chunk 103 was left to explain. So such kind of problem, if you don't think this way, then there can be problem in solving such a problem. So that's why I have chosen this problem, and I hope that you understand it.